Good evening, everyone. We'll get started. My name is Tori Perry-Mabida, and I'm the Director of Infrastructure Services with the Municipality of Meaford. I'd like to welcome you to the public meeting for the replacement of Gillies bridge number 15. This evening, we have our consultant Ainley Group who will be doing a presentation for you, and then we'll have a question period at the end. So I'll pass it over to James, who will be going through the presentation for us.
Thanks, Tori. Actually, before we get into the presentation, my name is Tammy Kalamutu. I'm with the Ainley Group. I do also want to welcome everyone. Thank you for your interest in this project and for your participation this evening. Before I pass it over to our Bridges and Structures team, who'll be taking you through the presentation, I just want to take the opportunity to explain to you a little bit about the platform that we're using tonight. So a couple of things to note. This presentation is being recorded. It will be made available on the municipality's website within the next day or two. Please give us some time for processing of the video as well as getting it posted on the website, but please rest assured that if for some reason you're unable to participate for the entire presentation, or if something happens, you lose internet connection, you will be able to access the full content of what we'll be discussing tonight on the municipality's website. Also, please note that this is more of a broadcast style presentation. So we're speaking to you, however, that is one-way communication. The presenters cannot see or hear you. So the only way that you can communicate with the team throughout the presentation is by using the questions and answers feature. To find this feature, if you look to the top right corner of your screen, you should see something that resembles a chat box with a question mark in it. And if you click on that, it will take you to a location where you can type out your questions and submit those to the project team. We will have people in the background collecting all of the questions. And as Tori mentioned, there will be a question period at the end, at which time we'll read out the questions that have been received and provide responses to those. Certainly, once you hear our responses to those, by all means, if you want to submit supplemental questions, you can do so. The only thing that I do want to highlight is there is probably about a 20 to 30 second delay or lag between the time we will receive those questions to when we will provide a response. So please be patient as we get through the presentation. So now I'll introduce you to the project team members that we have here tonight. Brian Wickenheiser is our Bridges and Structures Group Lead. He has approximately 25 years of experience leading bridge replacement and rehabilitation projects, many actually for the municipality, as well as several throughout Simcoe County and across Central Ontario. He is a licensed professional engineer, and he'll be the one that's in the background collecting all of your questions through the presentation and providing responses at the end. We also have James Baldwin with us. James is one of our structural engineers, and he's actually the project manager for this particular assignment. James is also a licensed professional engineer, and he has approximately 10 years of experience in the industry. So I'm going to leave it in James's capable hands to take you through the presentation this evening. Just turn it over to him.
Okay, thank you, Tammy. Okay. Tonight I'm going to be providing you with a little bit of background information related to this project and why the municipality needed the full bridge replacement. I'm going to provide you with the planned improvements associated with the replacement, as well as the construction impacts that will include frequently asked questions, as well as what still needs to be done moving forward. I don't expect this presentation to take the full hour, so there will be time at the end for questions to be submitted, as was previously mentioned by Tammy. So the project background. Okay, so we've got the bridge in question is located on Side Road 3, approximately 1.7 kilometers west of Grey Road 29, which is about 5 minutes southwest of Bognor and approximately 25 minutes from both Meaford and Owen Sound. The existing bridge structure is assumed to be built in 1940. However, it could have been built anywhere between 1940 and 1950. It is a single-span concrete rigid frame structure with a total deck length of 16.3 meters that provides a 7.3 meter wide driving platform between the curbs, which is about 3.65 meters per lane. This bridge is in place to allow vehicles to travel over the Big Head River, and the span of the existing bridge is currently 15.24 meters, or approximately 50 feet. This section of Side Road 3 is considered to be a low volume road with an average annual daily traffic volume of only 55 vehicles. So the road and the bridge are mainly used for local residents and some agricultural equipment. Structure condition. So we've got about an 80-year-old structure. Most of the bridges at the time were designed to have a lifespan of 50 to 75 years. In accordance with the Public Transportation and Highway Improvements Act, standards for bridges, it is mandated that all bridges be inspected under the direction of a professional engineer once in every 2 calendar years. These inspections are in accordance with the Ontario Structural Inspection Manual, or OSIM. Ainley Group has completed the biannual inspection on this structure for the municipality since 2016. Due to its condition in the 2016 inspection, the bridge was posted with a 12-ton load limit in 2017, and this was done in accordance with the Highway Traffic Act. We again completed the most recent OSIM inspection, and the resulting bridge condition index rating was calculated to be 24.5. I'll give you an idea, this is basically out of 100, which was one of the lowest in the municipalities. There were large potholes on the concrete deck for the structure, poor deck drainage, medium and large horizontal cracking on the underside of the deck, the soffit, and the wing wall, all of which had rust staining and efflorescence. The barriers and curbs on top of the bridge had large spalls, exposed rebar, and large sections of disintegration. In short, the bridge was in poor condition. Ainley Group completed a high-level life cycle cost analysis, which takes a look at the cost of rehabilitation and the amount of life in years the structure would be good for, or alternatively, a total replacement of the bridge structure, which should be designed for a minimum of 75 years. This was deemed to be beyond the point of economical rehabilitation. As such, Ainley Group recommended that the bridge either be replaced or, given the low average annual daily traffic it services and the availability of alternate routes, consideration should be given to closing the bridge permanently. In the end, the municipality made the decision to proceed with the bridge replacement. Planned improvements. Options considered. So I'm going to take you through some of the design options that we considered during the preliminary design phase. This will include the bridge and road cross section or platform, which includes the lane width, the shoulder width, and the bridge side clearance width, which is between the lane and the barrier of the bridge. We will also look at the bridge types, including timber, fiber reinforced polymer, concrete rigid frame, which is similar to the existing bridge, concrete deck on steel or concrete girders with both integral and semi-integral configurations, which are used to eliminate the expansion joint on bridges. Expansion joint on bridges have been shown to be the leading cause of deterioration due to water finding its way through these joints and then deteriorating the concrete or steel girders on the abutments below. We will also look at the bridge geometry, including the span orientation and placement within the existing road allowance owned by the municipality, as well as take a look at different barrier systems running across the bridge. So proposed improvements. Let's start with the road cross-section design. Since the existing bridge structure has a platform of 7.3 meters between barriers, the municipality asked for the replacement bridge structure to have a platform width equal to or greater than the existing bridge structure. The thought was, if agricultural equipment was able to pass on the existing bridge, then we should be able to provide enough space for them to cross on the new bridge. So we based our initial design on this and took into consideration that Side Road 3 is a rural, undivided road with the design speed chosen by the municipality. That, combined with the average annual daily traffic count of 100 vehicles or less, including 25% trucks and farm equipment, we were able to determine the required road and bridge platform. Based on the design manuals and codes, we determined the practical lower limit of the lane width is 3.25 meters. Similarly, we determined the lower practical limit for a shoulder width to be 1 meter, and that the bridge side clearance width needed to be a minimum of ½ meter from the lane to the barrier. However, the bridge side clearance width combined with the lane width provided a total platform of less than the existing bridge, and it's standard practice to avoid narrowing the bridge platform at the bridge structure, or narrowing the road platform at the bridge structure, as it makes drivers feel less safe when approaching a bridge. So therefore, We provide a lower limit recommendation to have the road and bridge platform to be equal and for them to be 8.5 meters in total, which is 2 3.25 meter lanes plus 2 1 meter shoulder / bridge side clearances. The municipality chose to move forward with this configuration, which are both wider than the existing road and bridge platforms and can accommodate larger agricultural equipment. Proposed improvements. Bridge type. So, based off the existing site topography, geotechnical information, existing bridge geometry, anticipated road platform, vertical, horizontal alignments, and the hydraulic capacity requirements of the replacement bridge structure, we explored a number of different options. We completed pre-consultation with the Grey Sauble Conservation Authority and determined that the new bridge should provide a similar conveyance or hydraulic capacity. That way, we would be able to avoid flooding either upstream or downstream. So what does this mean? We basically needed to match the existing span and soffit elevation as closely as possible. Further, from the topographic survey, GIS data, and aerial imaging, we determined that the existing watercourse crosses the existing road at an approximately 35-degree skew to the center line of the road. However, the existing structure was designed and constructed with no skew, which resulted in significant scour of the watercourse adjacent to the bridge structure due to forced redirection of the Big Head River. As such, we decided the new bridge structure would need to be skewed to match the existing watercourse more closely. Also, we did not want to raise the road profile any more than we had to, since this would cause the limit of road construction to extend onto the north or the south private property, which would then require the municipality to have to acquire a portion of these properties. So, to save money and to save time, we were constrained on the amount we were able to raise the road platform. Considering that typically 75-year or greater lifespan is required on new bridges, the requirements to match the existing road platform to avoid property conflicts and the requirements for a low maintenance bridge structure, timber and aluminum materials were quickly eliminated from the superstructure design options. FRP was also eliminated due to the performance issues and concerns of long-term durability. So therefore, we were quickly left with reinforced concrete or a steel/concrete composite structure as the main design option for the superstructure. Based on the geotechnical report, it was determined that steel H-piles would be the best option for the foundation on the structure. One of the better ways to transfer the load from the superstructure to the steel piles would be through a concrete abutment. Additionally, seeing that the abutment would be in contact with the watercourse either part or full-time, concrete abutment made the most sense to reduce the maintenance cost and extend the lifespan of the structure. So the substructure was basically complete. Given that the existing structure is a reinforced concrete rigid frame bridge, and that these structures typically perform well and generally have a long service life as a result of lack of expansion joints in the bridge deck, this system was considered for the replacement bridge. However, construction of a rigid frame structure would require the use of significant false work to support the bridge superstructure during construction, which is both costly and would potentially impact flows under the bridge and fish habitat during construction. Further, given the limited in-water works timing window of June 15th to October 1st, as provided by the Grey Sauble Conservation Authority, we did not believe that this window would provide sufficient time to complete the in-water works portion of the construction for this bridge type. As such, we believe that the concrete deck on girder bridge of either semi-integral or integral abutment configurations was the best option for the replacement bridge structure. In order to minimize the span length of the bridge structure and provide a 35-degree skew to match the watercourse alignment, as a semi-integral configuration would be required, as the skew exceeds a maximum recommended skew angle for an integral abutment bridge structure. From there, we began to look at the use of either steel or concrete girders. For steel, both rolled W sections and built-up WWF sections were considered. And for concrete girders, pre-stressed NU, CPCI, box, and hollow slab girders were considered. So we needed to match the existing soffit elevation. We wanted to minimize the changes of the road profile and grade over the bridge structure. To do this, we needed a relatively thin superstructure. Based on the span, this meant that we needed to use either pre-stressed box or slab girders, as the other girder options are typically much deeper. Although hollow core slab girders are shallower, the necessary girder was heavier than the box girder required for this design and would have resulted in more pre-stressing. So we chose to move forward with the box girder. We double-checked to make sure that the limit of road construction did not encroach onto private property with the additional thickness of the box girder, and we were basically set with a 150mm concrete deck over side-by-side pre-stressed B700 concrete box girders as our superstructure. All that was left was to pick the barrier to run along the bridge. Barriers are based off of crash test levels, with test level 1 being the lowest and test level 5 being the highest. Taking into consideration the posted speed, traffic volume, etc., as well as the applicable codes and standards, we narrowed down the bridge barrier options to the test level 4 F-shaped barrier and the test level 4 3-tube railing on curb. The second option is typically a cheaper option and has the added benefit of permitting flow through the barriers should the water overtop the road during large storm events, and therefore was the option chosen by the municipality. Since there is also to be steel beam guide rail attached to the bridge structure running both to the east and west approaches for vehicular safety, concrete end panels were provided at the ends of the bridge barrier for ease of attachment. And the steel beam guide rail lengths off the end of the bridge were determined in accordance with the applicable codes and standards. Additionally, in tribute to Gillies family that live on the property adjacent to the bridge for some time now, a plaque naming this structure Gillies would be installed on one of the barrier end panels. And thus we have our proposed structure. This is the elevation view of the bridge. As you can see, it has the majority of the final design options I spoke about, but this view also shows the river stone to be placed in front of the abutments and into the embankment. And this is a form of scour protection. However, there are a lot of lines on this view and they're hard for me to explain, so we have a different view of the bridge. One of the many talents of Ainley Group is that we can provide structure designs in full 3D models, and from there we can develop 2D drawings used for the tendering and construction of the bridge. Hopefully this gives you a better understanding of the proposed bridge design. The blue lines are to represent the Big Head River flowing under the bridge. You can see the steel pile foundation with the pile caps. You can see the concrete abutments that are skewed with the wind walls extending out. You can see the concrete deck with the semi-integral design of the superstructure. And you can also see the 3-tube railing on the curb barriers, along with the concrete barrier end panels. The steel beam guide rail and paving are not shown, but the guide rail runs about 60 meters off the end of the bridge, and the paving extends about another 10 meters past the guide rail. Construction impacts. Detour. Okay, so one of the main impacts from this bridge replacement is that the municipality chose to close Side Road 3 between Grey Road 29 and 4th Concession South. This is a much more cost-effective solution than providing stage construction that would keep one lane of traffic open during construction. If we went that route, given the in-water timing window, the bridge replacement would be completed over 2 years. As it stands now, the bridge is scheduled to be constructed between June and November of this year. During that time, Side Road 3 will be closed to through traffic, and only local traffic will be permitted to access Side Road 3. However, the bridge will be closed and the public will not be able to access the construction zone. With the bridge being closed, through traffic will be directed to follow a detour route following 4th Concession South, Side Road 6, which is just north of Side Road 3, and down Grey Road 29. Impacts of construction. So, other impacts include minor tree and vegetation removal that are required for the reconstruction of the bridge and the road approaches. Since this project is not scheduled to go to construction until after the migratory bird nesting window, the municipality is completing a separate advanced tree clearing contract before the beginning of the nesting window. This is to ensure that there is no delay for the contractor given the tight in-water works timing window. However, this is tree clearing only, which involves cutting the trees to a minimum height above ground and removing all the trees and limbs from site so no birds are able to nest within the construction zone. The subsequent grubbing, which is basically the root removal, will be included in the bridge reconstruction contract. There will also be a requirement for the contractor to access private property on the north and south side of Side Road 3 so that they may be able to fill in the scoured areas caused from the existing bridge not being in line with the watercourse. This is only minor fill operations with subsequent topsoil, seed, and cover restoration works. Now, from my understanding, the municipality has already been in contact with the property owners and an agreement is being entered. With raising the deck of the bridge, we will need to raise the existing road profile to match into the proposed structure. With increasing the road profile, we are providing an improved geometry and sightlines that will more closely match the posted speed than what is existing. Additionally, cautionary reduced speed signs will be posted on either side of the bridge. Further, with raising the road profile, we were also required to realign the existing center line of the road to be in the center of the municipality-owned right-of-way. This was to ensure that the limit of road construction did not encroach onto the north or south properties, requiring property acquisition from the municipality. Additionally, we're going to be providing steel beam guide rails along the approaches of the new bridge, providing additional safety for errant vehicles from entering the ditch or the watercourse. Also, to reduce the amount of gravel being tracked onto the bridge and reduce the amount of maintenance required in front of the steel beam guide rails, we will be providing asphalt pavement for the full length of the steel beam guide rail. All of these will improve safety of any driver in the event of an accident. With the addition of the steel beam guide rails, the existing field entrance to the southeast of the existing bridge will need to be relocated further to the east. It is my understanding that the municipality has already made an agreement with the property owners regarding this relocation. So, some frequently asked questions. What are the construction timelines? Construction is anticipated to commence on June of 2021 and be completed by November of 2021. Now, this is pending the tendering process, the agency approvals, budget, and council approvals. What are the construction costs? Construction costs are anticipated to be close to $1.6 million for this replacement. Will the load limit be removed from the new bridge? Yes, the new bridge is being designed in accordance with the Canadian Highway Bridge Design Code, so the load limit can be removed at the municipality's discretion, and it is my understanding that it will be removed. What if I have a concern during construction? You can either contact the municipality's project manager or the Ainley Group contract administrator / inspector. Our contact information will be made available for everybody. Some common concerns are dust and mud. However, seeing that Side Road 3 is already a gravel road, I don't believe that this is going to be a huge issue. Noise and vibration. So there will be some pile driving for the foundations. That is going to cause some noise and vibration. However, the next closest property to this bridge is fairly far away, so any vibrations will be dampened by the time it reaches the house, so there shouldn't be any structural impacts. What if I have a concern once the work is completed and the contractor has left? So the project will have a 2-year warranty period. And if you do have concern, it should be brought to the municipality's attention. And if it is warranted, it will go through the proper pipeline and it will end up to the contractor and they shall remedy whatever is your concern as long as it's within the warranty period. So next steps. So we're still waiting on agency approvals from the Grace Isle Conservation Authority and Transport Canada. We need to go into tender for this contract, which I believe is going to be happening next Thursday, which is March 25th. And subsequently, we need to award the contract, which I believe is scheduled to happen on May 17th of 2021. And also we've got construction, which is going to commence sometime in June, I believe, of 2021. Now remember, during construction, please be patient, exercise care and caution in the area. And if you have any questions, they can be sent to Joel Saunders of the municipality of Meaford, or myself, James Baldwin, of Ainley Group. And we'll be happy to answer any questions that we can. Okay, so now we're going to have some time for some questions. Like I said, this presentation wasn't going to take the full hour. Hopefully you've submitted some questions and Brian has been collecting them in the background and formulating some responses, so I'll turn it over to him.
Sorry, thanks, James. Yes, we've received some questions at this point here. So what I'm going to do is I'm going to basically read out the questions that have been submitted here and provide basically a verbal response for everybody on these ones here. So the first question received was related to the age of the structure. So somebody asked, with the bridge being so old, did you determine if it has any heritage value? So as part of the scope of work for this project here, the Ainley Group did complete a cultural heritage evaluation of the bridge structure. The findings of that cultural heritage evaluation were that the existing bridge, despite its age, did not demonstrate any cultural heritage value. However, there was a recommendation made and noted, which the municipality, I understand, plans to implement, and that is that the bridge, given the fact that the Gillies family have lived directly adjacent to the bridge for over 150 years, it was recommended that the bridge be formally named the Gillies Bridge, and in recognition of that, the municipality intends to install a plaque on the bridge that will have the name Gillies Bridge attached to the bridge. Okay. Another question we received here was, do you have a photo of what the bridge will look like? I think that question was actually submitted before the 3D model was displayed, but unfortunately, obviously, given that the bridge is not yet constructed, we don't have any photos of the bridge. I could probably find some photos of similar bridges or similar systems that could be shared ultimately if somebody was interested. However, I do believe that the 3D model that was presented probably gives the best overall image of what the bridge looks like at this point. It gives you should give a pretty good feel of what the bridge will look like. In particular, the components of the bridge that are going to be most visible are obviously going to be the top of deck and the barrier system, and I think that those are fairly well displayed on that 3D model. Next question received was, will we receive advance notice of the actual date the road is being closed closer to that time? So as part of the contract documents, the contractor will be required to fabricate and install road closure information signs, and they should be erected at least 1 to 2 weeks prior to the start of the road closure. Additionally, we will be preparing a notice of the construction and the road closure, which will be circulated or delivered to all the people in the immediate vicinity of the bridge. They're basically the local people, and additionally, the municipality will be posting that notice, I believe, on their website. Okay, some of these questions came in here too later, so I don't have answers yet for them. I'm just looking at here. So one of the questions was, this area is used by tourists frequently in the summer because of its picturesque views. Has the design taken into account the visual appeal of the area, particularly the railings and barriers, including preserving the big willow tree with the rope swing? So that's always one of the aspects we're looking at doing, is we're trying to, where possible, make an aesthetically appealing bridge structure. Obviously, there's limitations. We have to obviously meet the crash test requirements for the railings and barriers for the bridge, which limits us in some of the creativity that we can implement with respect to that. However, the barrier system being utilized as sort of a minimalist system. It is basically 3 steel tubes. It is a fairly open railing, which in fact will obviously allow for a better view of the adjacent land and the river when crossing over the bridge structure. It's going to be galvanized steel with concrete end posts. The bridge, I don't think the bridge should detract from the area. I think it should, obviously, being a new bridge, should look better than the existing bridge structure. But it should not detract from the area and should not limit your view of the adjacent area. However, the note about the big willow tree with the rope swing, I'm assuming that the person is asking about the willow tree directly adjacent to the corner of the bridge. Unfortunately, due to the reconstruction process involving the coffer damming of the watercourse, the regrading in the area, and as a general maintenance requirement, unfortunately, that tree directly adjacent to the corner of the bridge will be removed as part of the construction. We also had a question here from Councillor Greenfield. It says piles, how many on each side and how deep will they be driven? Is it possible to go back to the slide for a second, Tammy, showing the 3D model at this point? Just so I can confirm the number of piles myself here. So looking at this here, I think there are 12 piles total under each abutment, and they're to be driven, I believe, approximately 20 meters deep is my recollection. So they are to be driven to refusal. It was 15 to 20 meters, I believe.
Sorry, Brian, that's incorrect.
Sorry. Okay.
Yeah, there are 12 piles per side, and they're going to be driven approximately only 8.5 meters deep.
Below the bottom of the abutment?
Yes.
Okay, so there'll be about 12 meters or so below top of road. Okay.
Yeah.
Okay. Another question that came in was, will most construction equipment come to site from the east on side road 3? It's hard to say. I mean, obviously when the road's closed and the existing bridge is removed, likewise the contractor, as will the public, they will not be able to cross over the river. So we will have probably construction equipment coming in from both sides of the bridge. Obviously equipment will need to access it for the pile driving, the excavation, and the construction of the abutments. Equipment likely won't be able to cross over the bridge until such time as the deck has been cast and has achieved probably at least 75% of its design strength, which is roughly 7 days. So we anticipate that there will probably be about equal amount of construction equipment and materials coming in from both sides. However, we do anticipate if the contractor has a primary staging or laydown area, it will most likely be on the east side, because I anticipate that they will want to access side road 3 from the county road as much as possible. And I think that's it for questions at this point here, from what I can see. Okay, so as mentioned and on that slide there, if there's any further questions, feel free to contact either Joel Saunders at the Municipality of Meaford or James Baldwin of the Ainley Group here, and we will attempt to get a response back to you as soon as possible following receipt of your questions.
So thanks, Brian. At this point, technically the live presentation is generally finished. However, the project team will remain on the line until 7 p.m. That is when the event is scheduled to go until. So if anyone does have additional questions, please feel free to submit them through the question and answer section, and we will come back on and answer those questions. We'd like to thank everyone for attending. Again, we appreciate your participation and interest in this project. Tori, I'm not sure if you had anything else you want to add, but by all means.
Thank you, Tammy. Yeah, just thank you everyone for coming out and listening to the presentation and for your questions. They're greatly appreciated, and we're always glad to hear from you. And if you do have any more questions, we're happy to answer them following this. And as Tammy has said, this will be live on our website so that you can rewatch anything you need to or pass it on to anyone else who wasn't able to attend tonight. So thank you, and if you do have any more questions, we'll be here to answer them. So it looks like we had another question come in, so I'm just going to answer it for everyone. So the question was, the road closure will affect milk trucks and perhaps mail delivery and school bus travel. The milk truck will have to come down the steep hill to the west. Does it travel that hill now? When will fire, EMS, police be notified? So I guess I'll start with the beginning of this. So yes, as on many of our roads, we have a variety of different vehicles that travel down them. And in our rural areas, there definitely are certain agricultural vehicles or other industry vehicles that access them. So I'm not sure where these vehicles come from now to access these properties. However, when we were looking at the detour routes, we were trying to find a detour that would have the least impact on these vehicles and not be too hilly or beyond too narrow of a road. So that's why we chose the location that we did. Vehicles can choose to travel, I guess, in different locations if it benefits them and where they're coming from. And so all of the different vehicles, such as the mail, school buses, as well as fire, EMS, and police, will be notified at the beginning or following award of the contract to a contractor. And so they'll be given enough notice to ensure that they change their routes so that they aren't impacted by the road closure, but the detour signs will also be posted. So if for some reason they aren't aware, if it's someone who's out of the area, they'll be able to use that detour as well. So we have provided that detour route to make it as simple as possible for people to get around the construction area.
Okay, it looks like we had another question come in here that's sort of engineering related. So the question was, why is river rock being used to protect the banks from scouring instead of heavier and more angular shot rock? The primary reason that we use a rounded river stone, and when we say river stone, it's not that it's been taken from rivers. It's generally rounded field stone, but it's been given the term generally by the conservation authorities as river stone or river rock because that's what they typically want to see installed in the rivers. Generally, the thought process is that the more angular stone it can create a hazard to both fish and terrestrial wildlife moving over it. So it's generally frowned upon to use angular stone in the rivers, and it's usually a permitting requirement that we only use rounded stone for that purpose. However, unfortunately, given the fact that it does not have the same resistance to shear flow from the river, we do tend to have to use a slightly larger size. Additionally, above the water level, we tend to fill the voids or spaces between the river stone with topsoil, and we seed the area. The vegetation interlocking with the river stone tends to provide a significant increase to the shear resistance or scour of that stone. And once we get that all stabilized along the banks, we find that it performs quite well during the large storm events and the high river velocities.
So it is now 7 o'clock. We'd like to thank everyone for coming. There doesn't seem to be any more questions, so I'm going to pass it over to Tammy for some final comments. But thank you, everyone.
Thanks, Tori. So once again, we just want to thank everyone for your interest in this project, for your attendance this evening. By all means, if you do still have additional questions, you have the contact information for both Joel and James. Please do feel free to contact them and they'll be happy to answer any additional questions you have. And remember that a copy of this video will be available on the municipality's website within the next day or two. Again, we thank you for attending. We certainly hope that you're all staying safe and healthy, and have a good evening.